Okay, so in this video, what we're going to look at is a perpetuity. So the perpetuity is an annuity where a permanently, this is important, a permanently invested sum of money provides regular payments that continue forever. This value does not change. So, and this is why in a lot of scholarships and grants offered to students at universities are provided by funds known as perpetuities. So somebody would say, all right, he's 20 million, and the university would say, put it into a perpetuity, so that 20 million always stays there. That doesn't change, but each year a certain amount, whatever that money happens to be, will be given it out as a scholarship, and that money will stay the same each year. Okay, and so we're going to use formulas that which we've seen before. So we use stuff like D equals, there's a slight difference where D equals V0R, so it's a yearly thing, so we're not worrying about that N bit, divided by 100, and because it's only that one annual payment, so it's an annual regular payment per period. Now this works most of the time, and I do have really bad arrows, as you can see, but there are some examples which we'll go for where we need to use Finance Solver. Okay, we can transpose that to these two particular formula, where I'll do it in terms of V0. So if I know how much I'm being paid per period and I know the interest rate, I can just work out V0, or conversely, if I want to work out R, I use that formula there. Now, in terms of some worked examples, this first one is not strictly a perpetuity. It's just a different way that you can invest your money. So it's just a bit of a, let's show you something a little bit different there first. So what it's saying is you're going to invest, this person's invested 5 grand in a managed fund. That's this value here. Okay, and that's our time period 1. So we can call that V1 here. All right, so that's V0. This will be V1. I should write it like that. Okay. And that's 5 grand. It will be earn an average 8% per annum over a 2-year period with interest calculated monthly. Okay. If he contributes $100 at the start of the 2nd, 3rd, and 4th and 5th months, complete the thing. So basically what this part here is saying, is when I've got this part here, I'm going to go V1 plus 100. V2, so we go V2, V3, V4 plus 100, V3 plus 100, V4 plus 100. Okay, and that was give us our V5 here. Okay, so how we calculate the interest? Well, what we're going to do first is let's have a look. We're going to say 8% per annum. Let's convert that to a decimal first. So that's 8 divided by 100 will give me 0.08. Now I want to do it calculated monthly. So I want to know how much interest I'm paying per month. So I'm going to go V0. So that's 5,000 times 0.08 divided by 12. So that's 12 months. That will give me $33.33. Okay, so now I go, that's my V1. Now I go V1 plus 100. So now I go, so not balance, I put the balance wrong there. This value here is 33.33. So my balance is 5,033.33. And then I add 100 to that. I go 5133.33. I do this part the same here. So that becomes 513.33. And that will give me a value of 5167.5 5. Okay, so that's my V2. I go V2 plus 100. That gives me 526755. I do that times that. Bang, I get a value here. Then let's just sort of, I'll go get color there. That's going to be a color. I'm just sort of saving time a bit. 100, etc., etc., etc. And that's a recursion. So this is a recursive, as I'm going down, this is a recursive process. Okay, so keep that in mind. Now, so that's where I'm contributing. So here I'm calculating the annual perpetuity. Okay, so in this worked example, Robert wishes to travel. Robert wishes to use part of his wealth to set up a scholarship to help fund young students. So he's going to give 200 grand. Okay, and this is a perpetuity, so interest. So that's our V0. That's our R. We're using this equation here. So I'm going to go D equals 200,000. Oops. Times 4. Divide that by 100, and that will give you $8,000. So answer there is D. That's sort of a simple perpetuity type question, but you will get asked questions and saying, you know, in this one, after 10 years, how much, what money would be left in the account? The answer would be 200,000. That's what a perpetuity is. That 200,000 is not changing. In this case, I'm not adding any more money. I'm not saving that 8 grand because that goes to a student. I'm keeping the 200 grand as is. Okay, so in this case, as we've got these equations here, now I'm going to do worked example 22 here. I'm actually going to use basically what's from the book, just because it does get quite wordy. It'll take quite a while to work through, and I don't want to sort of completely bore you to death here. Okay, so what have we got? Rotary Club has 100 grand to set up a perpetuity. So again, that would be our V0 as a grant for local junior sporting club. The club invests in bonds that return 5.2% per annum. So that's going to be our R. Find the amount of the annual grant. So basically it's saying what is D. So this is what we're looking for here. So remember we said that was V0. V0 was 10 grand. That was 5.2. Basically put in the equation as is, and you get a value of 5,200. So the amount of the annual grant is 5,200. What interest rate compounded annually would be required if the perpetuity to provide 6 grand? So I know you might have seen it there, but this is where you use one of these transpose ones. So in this case, we're going to use this part here because we're after the rate. Okay, that's what's got it there. But what we're saying now is we're saying D here is 6 grand. We already know V0, but we're saying we want D. So what interest rate do we require for this perpetuity to give me 6 grand per year? That's a 6%. Okay, if you had 250 grand and you wanted 10 grand, you'd put 10 grand here, 250 grand there, and that would give you a whatever interest rate you needed for that. Okay, so question C. Let's bring C. Wants to investigate the other possible arrangements for the structure of the grant. How much extra would the annual grant amount to if the original interest rate was compounded monthly? Okay, so remember, this is where it's really careful here. So annual grant amount, that's going to be PPY. Compounded monthly, that's going to be CPY. So that's going to equal 1, that's going to equal 12. And that's the trick here. And so when I say that's the trick, this is why we can't use the formula that I gave before, the D equals 1. We can't use this anymore. Okay, we can't use that. We have to use Finance Solver. Okay, so, and here's some things to keep in mind. So here's a summary sheet that I've prepared for you guys. So this is a perpetuity. And so what we need to put here is the PV, the principal value, is a negative, and the final value is a positive. Okay, so it's like saying principal value, I'm giving them money, they're giving me back. It's sort of that sort of notion there, but that's the same number. So if the number's 10, 10 goes there, minus 10, plus 10. Okay, so let's come back to here, to here, and that's what we're doing here. So our PV is 100,000, our FC is 100,000, but in the V0, I've got a negative in front of it. That's what I need to put into my calculator. N, there's one payment. The interest rate is 5.2 because we've got that from our question. The PPY, as I said, it's one payment per year. All right. The CPY, the compounding periods per year, is 12. I write 1 and 12. Normally, if you go 12, 12, it doesn't matter for sort of reducing balance loans and stuff like that. This one, it's vitally important you don't do that. All right, put that in your calculator. You're solving for PMT, and you get a value of 5,325 and 74 cents. Remember, it's money, so I've got to put in 74 cents there. Okay. So if the interest was compounded monthly, that's how much you would get per month. Okay. So comparing that to that first little, for part A, you're earning that little bit extra, about 125 bucks extra. Okay. And that's comparative sizes. That's what we're doing here. It's $125. So by compounding interest monthly, I can squeeze out a little bit more money than if I just do it as sort of one value. And that's where that benefit can be if you can manage that. So D, what interest rate compounded monthly? So remember, compounded, CPY equals, Y equals 12. 4 equal payments, that's PPY equals 4. It's 4 equal payments. This is PMT. We're after R. Okay, should have done that in a different color so it made a bit more sense. All right, so from that question, N, essentially one payment. I'm after R, as I said before. These values stay the same. Oops, except I have a minus in front of the V0. 1,500 is my payment. Okay. I'm making 4 payments per year, and compounding per year, it's 12. I put that in the calculator. I solve for R, and I get a value of 5.97%. Okay, and that is what you need to do for a question like that. So the statement would be an interest rate of 5.9% per annum compounded annually is needed to provide 4 equal payments of 1,500, correct 2 decimal places, which, if you think about it, 4 payments is equal to 6 grand, which is what question B was asking for. It needed 6%, so you only need 5.97% to get the same value. So that's a better option to go for. Okay, thank you.